Welcome back. This is an Aleks training video on identifying Bronsted-Lowry acids and bases. So a Bronsted-Lowry acid is any molecule that donates a hydrogen ion, so H+. A Bronsted-Lowry base is any molecule that accepts an H+ and then becomes something new, okay, receives it. So donates a proton as an acid, receives a proton or accepts a proton, and it's a positive, it's an H+, which is proton, is a base. Okay, so they're asking in this question, the highlighted molecule, is it a Bronsted-Lowry acid, is it a base, or is it neither? So you have to ask yourself, is it losing a proton? If it is, it's an acid. Is it accepting a proton? Then it's a base. All right, so the first one here is ammonia. Okay, is ammonia going to be an acid, a base, or neither? So let's look and see what ammonia becomes. So you have NH3, and then at the end you can see something very similar, NH4+. So do you see that has one more hydrogen and one more positive charge? So it's receiving a proton. If it's receiving a proton, then it has to be a Bronsted-Lowry base. All right, so that's how you do it. So what's the next? The next one is water. Is water receiving a proton and becoming something new, or is it losing a proton and becoming its conjugate base? All right, so let's look here. I see the ammonia, NH3 and NH4, those are looking similar. So I bet you NH3 and H4 is receiving, so the NH3 must be the base, ammonia must be the base. Where is the hydrogen coming from? Well, let's look at water. There's two hydrogens in water, and at the end, OH, that's related, so it's lost one. So the hydrogen has lost, the water has lost a hydrogen plus, an H+ cation, left you with the conjugate base hydroxide. So in the case here, it's acting as a Bronsted-Lowry acid because it's the donor of the proton that is accepted by the ammonia. All right, what about the third one? I have NH4+, that's ammonium. All right, what's the one that looks like it? NH3 looks like it. So that means that I had an H+ here, but I have one less H and one less positive, so it must be the donor. If it's the donor, it's the acid. What's receiving it? Well, here's a base. Here's the OH, so I add an H to it and it becomes water. So this is the base, this is the acid. So this is the Bronsted-Lowry acid. And what's the last one? I've got hydroxide. Well, this is the same. The hydroxide becomes water. Okay, so the OH becomes H2O, so that it becomes from negative to neutral. So it's receiving the proton. The ammonium has the H+ and becomes ammonia, so it's giving away the proton. So it's the acid. This is the base. So this is the Bronsted-Lowry base. All of them were either acids and bases in this example. But you're just going to have to ask yourself, am I giving away a proton? Am I receiving a proton? Or nothing having to do with a proton, then it would be neither.